Last time, a dying star tore itself apart and flung you across the galaxy. One carbon atom, lost in the wreckage of a sun that no longer exists. Tonight, that violence finally ends. And what comes next is, in its own way, worse. Nothing at all. For the next 10 billion years you do nothing, touch nothing, and go almost nowhere, alone in the dark between the stars. There is no air out here, no warmth, no sound, no up or down, because there is almost nothing to carry any of it. This is interstellar space, and it is the emptiest, loneliest place you will ever know. Picture the gap between stars not as a short hop, but as an ocean with no far shore. The nearest star to our Sun, Proxima Centauri, lies 4.2 light-years away, roughly 40 trillion kilometers of pure nothing. To cross that gap, light itself, the fastest thing in existence, needs more than 4 years. And you are not light. You are matter, drifting at a crawl, with all the time in the universe to kill. Out here the gas is so thin that, on average, a whole cubic centimeter of space holds about one single atom. One atom in a thimble of emptiness, a vacuum far better than any machine on Earth can build. In 2012, a human spacecraft, Voyager 1, finally crossed into this void and found it almost perfectly still. So you drift, and the next atom you might strike is, on average, far enough off that you may not reach it for a human lifetime. You are not in a crowd. You are not even in a line. You are one speck in a darkness that runs for light years in every direction. And it is cold, colder than almost anything your body could ever feel. In the densest dark clouds, the temperature sinks to about 10 degrees above absolute zero, roughly minus 263 degrees Celsius. That is barely warmer than the universe itself, which the COBE satellite measured in 1990 at just 2.7 degrees above absolute zero. There is no fire to warm you, no planet, no companion, only the faint afterglow of the Big Bang, washing over you forever. It is the leftover heat of your own birth, 14 billion years ago, now stretched thin and gone almost cold. So you hang there, frozen, inside a silence older than any world. And the strangest part is not the dark or the cold. It is the time. You will wait out here for 10 billion years, longer than the Earth has existed and longer than it has left. To grasp that, our planet is about 4.5 billion years old. You drift in this dark for more than twice the entire age of the Earth before anything pulls you home. Oceans, dinosaurs, cities, you. None of it has happened, and none of it can, for an unimaginable stretch of time. The sun you sit inside right now does not exist yet. Neither does the cloud it will be born from. There is only you, the dark, and a clock with no hands. But you are not perfectly still. Nothing in the galaxy ever truly is. The whole Milky Way is turning, a slow pinwheel of hundreds of billions of stars, and you turn with it. Our sun takes roughly 230 million years to circle the galaxy once, a span astronomers call a cosmic year. In your 10 billion years adrift, you ride that great wheel around the galactic center dozens of times over. You are not falling. You are orbiting, slowly, patiently, in the dark. And as you go, you pass through regions that are not quite as empty as the rest. Here and there the thin gas gathers into vast, cold structures, the giant molecular clouds. Some stretch hundreds of light years across and hold the mass of 1 million suns, simply waiting. From outside, against the bright band of the Milky Way, they look like holes, patches where the stars just vanish. The astronomer Edward Barnard photographed them for years, and in 1919 cataloged these dark markings of the sky. People once thought they were gaps in the stars. They were not gaps. They were curtains. They are clouds of gas and dust so thick they swallow the light of everything behind them. The astronomer Bart Bach studied the smallest, darkest of them and guessed, correctly, that stars were being born inside. And sooner or later, on your endless ride around the galaxy, you drift inside one. Now the dark is no longer empty. Now it is crowded with dust and gas and slow, secret chemistry. The dust is real, tiny grains of carbon and silicate, like soot and sand, each finer than the smoke off a candle. On the frozen skin of those grains, atoms meet, stick, and begin, over ages, to build. Hydrogen pairs into molecules. Carbon and oxygen lock together into carbon monoxide. The cloud fills with water ice, with ammonia, with the first faint chemistry that will one day spell life. There are even rings of carbon out here, 60 atoms closed into a hollow ball, the molecule called Buckminster-Fullerene. Astronomers confirmed its fingerprint in deep space in 2015, written into starlight that had crossed the dark for centuries. You, a single carbon atom, are now one grain in a cathedral of cold molecules, miles deep in the gloom. And still, nothing pulls you in. Still you wait. Forces do touch you, but too gently to matter, for now. Starlight drifts through, a faint pressure at your back. The cloud barely notices. Cosmic rays, atomic bullets fired from far-off explosions, streak past, and now and then strike. They keep the cloud faintly alive with chemistry, but they do not carry you home. Magnetic fields, threaded invisibly through the gas, hold the whole cloud in a loose, lazy web. For 10 million, 100 million, a billion years, the balance holds. The cloud neither grows nor falls. It is a held breath, light years wide, waiting for one small thing to tip it over. And here is the quiet truth of your long exile. Nothing out here is trying to save you. The cloud is too spread out, too gently supported to collapse on its own. Gravity is pulling. Gravity is always pulling, but the cloud pushes back, and the standoff lasts for ages. The physicist James Jeans worked out the rule in 1902. To collapse, a cloud must be massive enough and cold and tight enough to beat its own pressure. Below that line, a cloud simply sits there, frozen and patient, exactly as you have for billions of years. So you sit. The galaxy turns. Stars ignite and die in other clouds, far away, and you never feel them. Whole generations of suns flare across the Milky Way while you hang in the dark, untouched. If you tried to keep count of the eons, you would lose track. This is the longest, stillest, loneliest chapter of your entire existence, and almost nothing marks its passing. But the clock is not broken. It is only slow, and somewhere, the count is finally running down. Because clouds like yours do not wait forever. They wait for a push. And we know a push came, because the evidence is buried inside the rocks of our own solar system. In meteorites that fell to Earth, scientists found the ghosts of atoms that should never have survived this long. One is aluminum, 26, a radioactive atom that decays away almost entirely in just a few million years. Its decay leaves a chemical fingerprint, and that fingerprint is locked in the oldest grains of the Allende meteorite, which fell over Mexico in 1969. For that aluminum to be in our cloud, it had to be forged next door and forged fresh just before the sun began. And only one thing makes aluminum, 26, and flings it out that fast, a massive star dying in a supernova. So picture it. After billions of years of perfect stillness, a nearby giant star runs out of fuel. It collapses, then detonates, outshining 100 billion suns in a single, soundless flash. And a shockwave, tearing outward through the dark, slams into the edge of your patient cloud. The hell breath breaks. The blast wave squeezes the gas, packs it tighter, and shoves part of the cloud past the line James Jeans drew. For the first time in 10 billion years, gravity is winning. The region around you begins, ever so slowly, to sag inward, to fall toward its own center. The dust grains drift closer. The gas thickens. The dark grows deeper still. You feel it, not as a shove, but as a tilt, a long, slow lean in a direction that suddenly has a down. The cloud that ignored you for an age has finally chosen a center, and you are being drawn toward it. Everything you will ever become, a star, a planet, an ocean, a heartbeat, begins with this single, gentle surrender to gravity. The 10 billion years of waiting are ending, not with a sound, with a lean. Remember where this episode began, one atom, alone in the silent black, with nothing in all the universe to pull it in. Now, at last, something is pulling. The dark is gathering itself around a center, and you are falling inward with it. The silence that held you for longer than the earth has existed is finally, quietly, breaking. Next time, that falling cloud catches fire. Next time, caught in the birth of the sun, as you spiral into a newborn star and the longest night of your life comes to an end.